Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is colligative properties, boiling point elevation and freezing point depression. Colligative properties are unique physical properties of solutions that depend only on the number of solute particles present, not on their identity. Among these properties, boiling point elevation and freezing point depression play a significant role in understanding how solutions behave in different conditions. These properties have a wide range of applications, from antifreeze in vehicles to food preservation and even in biological systems. When a non-volatile solute is added to a solvent, the solution exhibits a higher boiling point compared to the pure solvent. This phenomenon is known as boiling point elevation. It occurs because the presence of solute particles disrupts the solvent molecule's ability to escape into the gas phase. In a pure solvent, molecules at the surface can gain enough energy to vaporize. However, when a solute is introduced, it reduces the number of solvent molecules at the surface, requiring a higher temperature to achieve the same vapor pressure needed for boiling. This means that more heat must be supplied to reach the boiling point. The extent of boiling point elevation depends on the concentration of the solute particles in the solution. The higher the number of dissolved particles, the greater the effect on the boiling point. This principle is widely used in industries where precise boiling points are necessary, such as in the manufacturing of solutions for cooling systems, pharmaceuticals, and even in food processing where consistency in boiling behavior is required. Similarly, the addition of a solute to a solvent leads to freezing point depression. This means that the solution freezes at a lower temperature than the pure solvent. This occurs because the presence of solute particles interferes with the formation of a solid crystalline structure. In a pure solvent, molecules come together in an orderly manner to form a solid when the temperature drops. However, in a solution, the solute molecules disrupt this orderly arrangement, requiring a lower temperature to achieve solidification. The concept of freezing point depression also plays a critical role in biological systems. Many organisms, such as certain fish and insects, produce antifreeze proteins that lower the freezing point of their bodily fluids, allowing them to survive in sub-zero temperatures. This natural adaptation prevents ice crystal formation within their cells, which would otherwise cause severe damage. In food preservation, the addition of solutes like sugar and salt takes advantage of freezing point depression to improve the shelf life of products. Ice cream, for example, remains soft even at low temperatures due to the presence of dissolved sugars and other solutes, which prevent complete solidification. In the case of frozen foods, brine solutions are often used to maintain a lower freezing point, ensuring that the food retains its texture and flavor even when stored for long periods. Both boiling point elevation and freezing point depression are colligative properties, meaning they depend only on the number of solute particles in a solution rather than their chemical nature. This is why ionic compounds, which dissociate into multiple particles in solution, have a greater effect on these properties than non-electrolytes. For instance, common salt, when dissolved in water, breaks into sodium and chloride ions, effectively increasing the number of solute particles and thus enhancing the colligative effects. Understanding these concepts is essential in many scientific and industrial fields. In medical applications, colligative properties are used in intravenous, solutions to ensure they have the right osmotic balance with human blood. Incorrect osmotic pressure can cause cells to either shrink or burst, leading to serious health consequences. Similarly, in the beverage industry, knowledge of colligative properties helps in designing solutions with controlled boiling and freezing points to maintain taste, consistency, and preservation. Both boiling point elevation and freezing point depression depend on the concentration of the solute rather than its identity. This means that the number of solute particles in a solution determines the extent of these effects, rather than the type of substance itself. This fundamental principle of colligative properties makes it possible to predict changes in boiling and freezing points for different solutions simply by knowing the amount of dissolved particles. Another critical application of colligative properties is in biological systems. Many organisms living in cold environments produce natural antifreeze proteins that lower the freezing point of their bodily fluids, preventing ice crystal formation inside their cells. This adaptation is vital for their survival in extreme conditions. The underlying reason for these effects is that when a solute dissolves in a solvent, it creates a solution with lower vapor pressure than the pure solvent. A lower vapor pressure means that the solvent molecules require more energy to escape into the gas phase, which is why the boiling point increases. On the other hand, because the presence of solute molecules disrupts the solidification process, more energy must be removed to achieve freezing, leading to a lower freezing point. In chemical research, colligative properties are used to determine the molar mass of unknown substances. Since these properties depend solely on the number of particles in a solution, scientists can measure changes in boiling or freezing points to calculate the molecular weight of compounds. This technique is particularly useful in laboratories where precise molecular information is needed for developing new materials and drugs. From everyday applications to advanced scientific research, boiling point elevation and freezing point depression are fundamental concepts in chemistry that help us understand the behavior of solutions. They demonstrate how the addition of solutes can significantly alter the physical properties of a solvent, leading to various practical uses in daily life and industry. Whether it's keeping car engines running in winter, making ice cream softer, or ensuring the proper function of biological systems, colligative properties continue to play a crucial role in shaping the world around us. Thank you. We hope this video has helped you gain a clearer understanding of hydrogen and its compounds, especially the fascinating role of heavy water and isotopes. If you found this video helpful, make sure to like, share, and subscribe to AskPrep for more in-depth chemistry lessons. Keep studying, stay curious, and good luck with your exams.